presentation, I'd like to share with you some of my experience in using NUS Grid in the Risk Management Institute Credit Rating Initiative. And the outline of the presentation is here. Firstly, I'd like to talk about the computation difficulties we encountered in the Risk Management Institute Credit Rating project. And then I will discuss why we finally choose to use the NUS Grid, and then how the grid helps to solve the problem and how the grid is being used regularly. And finally, I'd like to, based on my personal experience in using the grid, I'd like to give some suggestions on how the NUS Grid platform can be improved to further advance our research work. Firstly, I'd like to give a brief introduction on our credit rating project. And this non-profit project is being undertaken by NUS RMI with the intent to spur research and development in the critical area of credit rating methodologies. The project includes building a database including data on over 40,000 companies across Asia Pacific, and North American economies. And the credit rating model parameters are calibrated monthly, and default probabilities forecast for each firm are updated daily. And in the model, the distance to default is a very important input, and it is the firm's volatility adjusted leverage measure. We estimate the parameters for distance to default for each firm each month using the previous 20 years of daily market capitalization and financial statement data. It is difficult to compute DTD because we have a very large data set which includes 20 years of data of more than 40,000 firms, and the computation algorithm is complicated. On the local PC, each firm needs around 2 minutes computation time, and it may take a few days to complete the whole computation for DTD for all the firms. And we have tried several high-performance computation techniques like GPU, and finally we decided not to use GPU because we have bought a new machine, but it's for some other applications in this project, and some limitations of GPU machine limited its application in DTD computation, such as the special knowledge in hardware and software are needed, and the slow development speed. And the scalability is not so good as on Grid. In addition, GPU is a quite new technology, and some functionality is not ready yet for this application. Therefore, we will finally choose to use the Grid for the DTD computation. And the nature of the DTD computation algorithm is highly parallel, and thus it is fitted to the Grid computing structure. And the NUS Grid significantly shortened the DTD computation time. We have created over 2,700 of files, and each contains 20 firms' data. And it takes only a few hours to complete the whole thing. And the Grid is simple to use. We can just follow the standard procedures like compile the MATLAB program and upload the compile program as an application via the platform on the website, and submit the inputs via few DOS command lines. And also I'd like to thank the staffs which gave us advice and suggestions on how to utilize the Grid during the project. And here is an example on how we use the NUS Grid. Here is the home page. And usually the first step is to compile the MATLAB program that we have on the Linux server by typing few command lines, and upload the resulted meta files as an application onto the NUS Grid via the application create and update wizard. And then is to zip the input files and submit onto Grid by typing one line of DOS command. The user just have to specify the application name, input path, and job description. And here is an example of the successful completion screen, and user have to take note the job ID that is generated by the system. And then after the submission, we have to check the job status at the platform continuously. Enabled means the job is still running, and completed means it's finished running and all jobs are done. And then after the jobs are done, we can retrieve the output files by typing just one line DOS command, and output directory containing the output files will be created then. And now I'd like to give some suggestions on how the Grid platform may be improved. And firstly is the user interface. And currently we have to make a few clicks in order to submit the application. And if the uploading application process can be implemented using command line, it will be, then our procedure will be more automated. And then is the control. If the user can be informed when the job is done, then we don't have to continuously check the job status by refreshing the website. And for the same reason, it's better that we have an estimated computation time and the information on the available resources so that the user can make the decision when to submit the jobs to avoid the traffic jam. I think that's all.